So hello all, I am Tirthesh. You are watching Tech Mania World of Knowledge. Today in this class, let us learn extend some more concepts regarding the logical gates. So yesterday we had completed NAND gate, NOR gate, XOR gate, NAND gate, NOR gate, AND, OR and NOT gates. Some basic gates and also we saw some two derived gates. So today let us learn what is XOR gate and what is XNOR gate and what is a circuit, logical circuit. How do we draw a logical circuit? Why a logical circuit is required also. So today let us start with the first topic as XOR gate. So what is this XOR gate? XOR gate is an exclusive OR gate. It is known as exclusive OR gate. What does it do? Here we have a two inputs is produced for a single output, or we can say has two input but produces a single output for any input combination. So what does it do? It has two inputs for a single output for any combination of the outputs. So you have seen when we draw a truth table here, for example, if I say two inputs means 191, it produces some value. So means for any combination of the inputs, it may be 1 or 0 or 0 or 1 or 0 0 inputs. So what does it do? It produces single output. So these things you know that. But the twist here is wherever you have odd numbers of ones, then your output will be high. Say for the example, you have an odd number of input over here. So what does it will become? It becomes the high input as high. If you have no odd numbers of inputs, then your input will be low. So this is what exclusive OR does. So exclusive OR, what does it say? It has two inputs. It has two inputs produced for one single output and for an input combination. It may be any varieties of things. So output is high only for those inputs which has the odd numbers of integers. So when we get the high input, when we have a odd numbers of ones, only then, when you have an odd number of inputs, only then your output will be high. If you doesn't have an odd number of inputs, then your input will be low. So this is the exclusive OR. So what does the exclusive OR say? Exclusive OR says that it can also have two or more inputs produces only single output for any combination of output. So output is high for those inputs who has odd numbers of ones. So take the example over here. So this is the truth table. Wherever we have odd numbers of ones. So this is even number. Here you have a even numbers. Here odd, and this is even. So wherever we have an odd number of ones, that's your output will be high. So this is a XOR gate. So XOR gate, what does XOR gate state? XOR gate states this is satisfied only when your input is in odd numbers of ones, but it is not considered by zeros. Clear? So next, so what does it do? So what does XOR gate does? Main key factors in XOR gate: accepts two inputs. What does it do? It accepts two or more input, but produce single output. You have seen all that. Next, output is 0 if there is even numbers of ones. If there is even numbers of ones, so 191, this is the even number called as 2, then your output will be 0. The output will be high 1 when you have an odd number of ones. Only when you have an output high, only when you have an odd numbers of ones. So this is how a XOR gate or exclusive OR gate works. So what is the symbol is? To represent the XOR gate, we use the symbol inside a bubble of plus. So this is symbol of XOR gate, and the logical diagram for XOR gate is like this. So what does it do? XOR means it is a negation. We always say it is negation. So when we draw OR gate, it will be like this. So this is the OR gate. So XOR gate means it is like this. So this is the symbol to work on XOR gate. So hope you understood XOR gate. XOR gate is known as exclusive OR gate or exclusive OR gate, or it is also some negotiation of the OR gate. So this is the XOR gate. So let us talk about XOR gate. So this is simply a opposite of XOR gate. XOR gate is simply a opposite of XOR gate. So what does the XOR gate do? So XOR gate produces the high output only when the input is in odd numbers. Same way XNOR gate means it is followed by NOT gate. XOR gate or XOR followed by NOT gate to produce XOR gate followed by NOT gate to produce XNOR gate. Okay. So what does it do? Even this produces this will provide you single output. Provides provide single output for any combination of one or more number of inputs. So what is the twist over here? Here this will always produces high input when you have even number of ones. So what does it do? When you check out the XOR gate produces the high output only when you have a odd number of odd number of ones. But this XNOR gate produces the high output. It produces the high output when you have even number of ones. It produces a high output or it produces ones when you have even number of ones. Means it produces high output when you have even number of ones. So when you have even number of ones, what does the XNOR gate do? It produces the output as high. It produces low output when you have odd number of zeros. So next, let us see how does this action of XOR gate and XNOR gate perform using our truth table. Okay. So what does the XOR gate do? It produces high output when you have odd number of ones, but XNOR gate produces high output when you have even number of ones. So that is XOR gate and XNOR gate. So let us check XOR gate, how does it work, and XNOR gate, how does it work. XNOR gate, how does it work using the truth table. So anyhow we know our numbers in the 4-digit format, please. 0 0 0 0 0 1 1 1 and 1 0, or let me take three variable format itself. 0 0 0 0, right? 0 0 0 1 1 1, sorry, 0 0 0 0 1 0 1 0 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 9 1. So X, Y and Z. So what does the XOR gate do? XOR gate produces the high output when you have odd number of ones. So here there is no one, means it is 0 itself, right? So 0 means it is not an odd number. So function 0 means it is not an odd number. So what we get? We get bit stop with 0 itself, right? So here odd number of 1. So 1. Here when you have odd number of 1 here, and here it is 0 because it is even. 1 0 0 and 1. So why it is 1 0 0 1? So you can see the function over here, right? XOR. It says when you have an odd number of 1, it gives us the output as high. So check out the statement here. So here it doesn't have an odd number, so this is even. Here this has 1, so odd. This has single one, so odd means only one is there. Here you have two numbers, so even. So here is the 1 odd. Here you have two numbers, so it is even. So here again you have two numbers, that is even, and this is odd. So this is how your XOR gate performs the action. So So what does the XOR gate do? It produces high output. When it produces the high output, only when it has odd number of ones. At that time it will provide high output. It produces low output when you have an even number of ones. So you can check out in the first line itself. So what does the first line do? First line has completely zeros. So no ones are there. Means no ones means the count of 1 is 0. So 0 is the even number. For that reason first we get 0 as the output. So let us check out XNOR gate, action of XNOR gate. X, Y and Z function. Okay. So let me write the function first. So number them 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 and 1. So what does the XOR gate do? XNOR gate produces the high output when does it produce the high output? When you have even number of ones. So now it is even number of ones. So this is x double 0 means it is even. So what does the output be? Output will be 1. So here you have odd number, here you have again odd number, here you have even number. So even number means your output will be high. So again here it is odd number, here it is even. Even means output will be 1. Again it is a even. So there are 2 ones, the output will be 1. 3 ones means it is odd. So this will be 0. So this is the output format. So you can check out what is the difference here. Here this XOR gate is opposite of XNOR gate. So how do I say output XOR gate is opposite of XNOR gate? Only because of the outputs. So whenever your output is high, it means that you have odd number of ones in XOR gate. When does the XOR gate has the high output? When it has even number of ones. So at that time your output will be high. So this is how action performed using the XOR gate and XNOR gate. So now let us see how do we draw a XOR gate. So how do we draw XOR gate and XNOR gate? Okay. So when we construct a circuit of XOR gate and XNOR gate, we should properly seek on that. Okay. So how do we do XOR and XNOR? Okay. So let me draw a very logical circuit for that. So whenever I am going to work on XOR gate, my logical circuit will be doesn't have NOT gate, because this is not a combination of NOT gate. So what I do, I just draw my OR gate first. OR gate. I just draw my OR gate. So I just draw my OR gate. Okay. Then this is the symbol of x plus y. Okay, XOR gate, or it is known as OR gate plus. So x, y. Clear. So this is the two variable logical diagram for XOR gate. When you get 3 variable, it will be 3 variable means you get 1 line extra, and 4 variable means you get 1 more line extra. So w, x, y, z, y and z. So this is how your XOR gate looks like. But when you are working on XNOR gate, it is there is a slight changes in a logical diagram, logical circuit or a gate, logical gate of XNOR gate. So how does the XNOR gate looks like? Same of XOR gate itself, remember. So what does the XOR gate have? It has a OR gate, okay, and OR gate, and here first you have x, right? So what we should do, we should put one more braces like this, and this is the combination of OR gate and NOT gate. So this is how XOR gate looks like. X, y means x into y. So the format or a symbol to represent XOR gate is one bubble with a single dot inside it. So that is the symbol to represent XOR gate. So whenever you draw 2 variable or 3 variable or 4 variable, just the input lines will extend, but the output line will be single. Understood? So x, w, x, y, z. So this is how we are going to draw a XOR gate and XNOR gate. This is a symbol or a logical gate. Logical gate logical gate of XOR, and this is the logical gate of XNOR. So hope you understood how do we draw XOR gate and XNOR gate. So now let us so this is the derived format or derived gates in the Boolean algebra. So why is this logical gates actually required, or what is the use of this Boolean algebra in the logical gate? So we are working on a concept of Boolean algebra. It doesn't sense only if you have Boolean algebra we can survive, but this Boolean algebra must be converted into a hardware. Only then we can work on a logical gate. So to convert the Boolean algebra into a hardware, we have a concept called as logical circuit. We have a concept known as logical circuit. Okay. So how do we draw a logical circuit? So whenever you are going to work on a Boolean algebra, so Boolean algebra is not a permanent solution. So a Boolean algebra is not a permanent solution. Why this Boolean algebra is not a permanent solution? Because we are going to deal with zeros and ones. So only a system may understand zeros and ones, but a human being doesn't understand what is this zero and what is this one. So what we should do, always this Boolean algebra must be converted into circuit. So what is a circuit? A circuit either be a hardware machine or a signal where a data we are going to transfer. So this transformation from a Boolean algebra through a circuit is done by logical gates. This logical gate circuit formation is known as a logical circuit. So what is a logical circuit? A logical circuit is a format where we are going to convert the Boolean algebra. Logical circuit is a format where we are going to convert the Boolean algebra in the format of logical diagram. So what does it say? A Boolean algebra is useless unless it is translated into a hardware in the form of gates. This translation of a Boolean algebra in the gate is known as logical circuit. So logical circuit is represented. So what does this do? So Boolean algebra, if a Boolean algebra is in the form of x plus y plus z. So this will be in the form of Boolean algebra itself. But these things are not being understood by your users. Okay. So what we should do? We should convert this into a user-friendly format using the logical gate. Okay. This conversion is known as logical circuit. Understood? So what is a logical circuit? A logical circuit is a translation of a Boolean algebra in the form of gates. In the form of gates is known as a logical circuit. How do you convert? How do you translate this in the form of gates? We are going to use the three gates which we have learned in this chapter, known as AND, OR and NOR. Basic gates. To convert this Boolean algebra into a gate form, we are using to basic gates. Also derived gates. So to convert the data, we are going to use basic gates and derived gates. Using this, we are going to convert them into a logical circuit. Okay. So using basic gates and derived gates, we are going to convert them into a logical circuit. So what are the steps required to convert this Boolean algebra into a gate format? So what we should do, first step is we need to how do we do that? Now let me take an example. Okay, so that you will understand more clearly. So my example will be like this. Okay, x bar into y, x bar into x plus y into x plus z into y plus z. Okay. So what do you find over here? You find three gates. One is plus, means it is a AND gate. Bar means it is a NOT gate. Next, into means it is a, sorry, plus means, into means AND gate, plus means it is a OR gate. Okay, into means AND, plus means it is a OR gate. Only these things you find. So when we draw AND gate means it is like this. AND gate will be like this. NOT gate will be like this. And OR gate will be like this. Understood? So we are going to use these three gates to convert this Boolean algebra into logical circuit. So let us see how do we draw them. Okay. Now we have the problem over here. First you have a NOT gate. What you should do? You should convert that X into a NOT gate format. Then you have a y variable means X bar y, which is in the OR gate format. Okay. Which is in the OR gate format. Next, what you have? X plus z. So there is no, what we say, there is no complemented variable. So we are going to directly draw OR gate. Next, y plus z. Y and z. So we are going to directly draw OR gate because there is no complemented variable. Okay. So now, together it forms. Using a AND gate. Together using a AND gate it forms. So using a AND gate it forms X. So using the AND gate it forms X bar. Wait a minute and show you properly. So what does it do? X bar plus y into X plus z into y plus z. So this is how we are going to convert the Boolean algebra into a logical gate. So this is the circuit representation. So hope you understood how do we draw circuit. So what we are going to mainly concentrate? We are mainly concentrating on the bars over here. If you have plus means it is a OR gate. If you have bar means it is a NOT gate. And if you have into means it is a AND gate. Using these concepts, if you draw a diagram or a logical circuit, then it is known as a logical circuit. Understood? So this is how this part is there, right? So whatever we are going to draw a logical circuit is further converted into a hardware, and these things are being directly used by our users. So this is for today's class. In next class, let us see how do we convert using a NOR gate and AND gate. So thank you.